So, in the last few lectures, we were looking at different types of ferrous alloys. We looked at steels. We looked at high carbon steels as well. So, in high carbon steels, the amount of carbon present was less than 1.4 weight percentage. Now, cast irons can be classified as those ferrous alloys in which the amount of carbon present is in the range of 2.14 weight percentage. Okay, generally mostly we see cast irons in which amount of carbon will vary from 3 to 4.5 weight percentage. Now, the important thing to note here is that when you have this much of a carbon content in your iron, which is the parent material, then there is a certain effect on the easiness or the ease with which the alloy can be melted. With the help of phase diagram, we can explain that. So this is a very rough schematic of the iron carbide phase diagram. On the y-axis you have temperature, on the x-axis you have the amount of carbon present in the alloy. As you can see here, when I have a 0% of carbon, melting point of my parent material, which is iron, is around 1538 degrees Celsius. The moment I keep adding carbon into the alloy, that implies we are somewhere here in this regime, then it can be easily melted. So the temperature at which we can see a liquid phase has come down. So this is a very particular characteristic of cast iron. It can be easily melted. That's why it is so amenable to forecasting. So we make a lot of components which are very intricate in shape by this process, or in other words, by using this particular material called cast iron. Now, another important thing. So we told the amount of we discussed about the carbon present in the alloy. Now what about the microstructure? See, in the phase diagram which we had just now saw, here is our iron carbide Fe3C, which has around 6.7 weight percentage of carbon in it. What happens is, since this ferrocementate is a metastable product, it will decompose under certain circumstances. It will decompose into iron and carbon, and this carbon will be in graphite form. The tendency of this particular reaction is depending upon certain things. The first thing is the composition. For example, if you have more than 1% of silicon in your alloy, then the probability of this particular reaction occurring is far more. So when you have more silicon in your alloy, then that means there is greater chances of carbon present in your alloy in graphite form, or you can see carbon in its graphite form if you have more amount of silicon. The other factor upon which this reaction or the tendency of this particular reaction will depend is the rate of cooling. So if you are cooling very slowly, then there is a larger chance for this particular reaction to occur. Then also you will see carbon in your alloy in the form of graphite. With this, now let me explain to you what are the different types of cast irons. These are the different types of cast irons which we usually encounter in industry. The first one is grey cast iron, the second white cast iron, third ductile or nodular iron. The fourth one on the list is malleable iron. The last one on the list is compacted graphite iron. The one way to remember these names, it's just a small technique. You can take it if you want, otherwise you can just leave it, no issues. The technique goes like this. So the first two names are, you can remember them by the color, gray and white. The other two you can remember by thinking of it like this. So ductile iron, malleable iron, these two terms refer to the mechanical property of an alloy or a metal. And then the fifth one, anyway, you have to remember. So the first two have something to do with the colors. The third and the fourth one has something to do with the property of the metal. And the final one has got something to do with none of the above two. You have to remember the name. I hope this video was useful. So in the next lecture, we will talk in detail about each of these type of cast iron. Thanks a lot.